Professor, this is my submission to our assignment 3, sort and search and trees. Firstly, we have sort and search. The first problem is utilize the sorting method we've been provided, quick sort, bubble sort, insert sort, and selection sort, to sort the deck both by suit and by value. And the suit in the order provided in the deck is created. So here is the our class of deck. Firstly, we have the suit by order, and then we create the sorted flag. So every time the deck is sorted, it will become true, and every time it's shuffled, it will become false. And also when the deck is created, it will become true. So by default, it's gonna be false. And then we have the deck index as a dictionary. So firstly, we have here is the functions I have overridden from Python default. The first one is greater than. So here we're gonna compare the suit first, and then we're gonna compare the we're gonna compare suit name, and then we're gonna also compare the suit value, and then it's the hash. So here hash function, we're gonna have the our card as a key, so we're gonna want to put it both suit and value into um, as a key to be enabled in hash. And then we have the repre function in Python. So here we're gonna just return our string function, string method ready in the card. So this will enable us to print the value and suit of the card instead of as an object. Okay. Yep. So let's get started of the initiated. So we're gonna create the deck, and as a already sorted one, we're gonna also write this function is to get that index. So this get index function basically is to get the index of each card. Firstly, we will clear all the existing index. So once we sort it or we shuffle them, we will get the new set of index. And as we can see here, we enable the cards as our key. So this will give us the position of the card once we entered the card. And then is the one we have to do is the sorted function. We're gonna just return to the sorted flag every time. Also, we have this string self, a string function. Here we're gonna just to print out whether the deck, how many cards of the deck, and if the deck is sorted by, if the sorted flag is true, we're gonna print out sorted, else we're gonna print unsorted. The next one we're gonna do is the sort function. So sort function here, we're gonna use the bubble sort, and then after the sort, first thing we do, we put the sorted flag as true. Then we're gonna get the new deck under deck index as a like a dictionary. So then we have the search function. So basically we're gonna use the describe card. So we're gonna ask you which card you want to serve, and then we're gonna once you enter the card information, we're gonna get the card index through our the deck index dictionary. So then we will have the search done, which will be easily and very highly intelligent, and this is gonna be only using a constant time lookup. So let's go to the main function to see the results. Firstly, we create the deck, and then we print the deck. We have 52 cards, and then we're gonna print the whole deck, so we can see everything is in sorted one. And then we shuffle the deck, so now and print it again. So now we see it's sorted. Then we're gonna do the search. So search, firstly, I just put it seven of diamonds, and as we can see, 7 of diamonds is at the 49th of the deck, which is the last threes of the threes. So 1, 2, 3, 4. Yeah, last fours. So then we're gonna do the sort. So once we sort it, so we can see still printed out how many cards we have, and also here we can look at our deck. So this is sorted in a way we want it, by suit and also by the number, by the value. So the first part of sort and search we have done, and for second part, the trees. So firstly, we have been asking like three tasks. Firstly, we're gonna populate a binary tree using the random numbers, and then we're gonna evaluate the number of leaf nodes in the tree we created, and then we're gonna evaluate the height of the tree we created here. So here it's just utilizing the code we've been provided. It's the tree here, and then we're gonna modify a little bit of our breadth first traversal in order to find the leaf nodes. So here we put another constant, another variable here. This will be the leaf node count. So first will be set to 0, and while we traverse the tree, once we found the leaf nodes, we're just gonna add this by 1, and then we're gonna return this value. In order to find out the height of the tree, we can just utilize any order the tree traversal method, like in order, post order, or pre-order, to giving back the height of the tree. So here, easy thing we're gonna do recursive way as given by our code. So the base scenario is if we reach the bottom we reach the leaf node of the tree, we're gonna return 0, and then we're gonna adding up the heights from the maximum from the left and the right. In this way, we will get the height of the maximum at the height of the whole tree. Okay. So here we're gonna just create our tree, read the CSV file, and then using the insert value to insert all the insert function or method from the tree to insert all the values from the random number, and to populate the tree. That's the first step, and then we will have our root node here. In another block, we're gonna use the method we create, the breadth first traversal here, just to look at starting from the root node. When we print out the number of leaf nodes in the tree, we have 31. So this is as what we are expected. And then we're gonna use the in order function we just created to get the height of the tree and print it out. So this is 14. It's also as expected. So we have finished our task here. Thank you.